Welcome, my name's Chris Van Dijk and this is the Build Better podcast. We're here today for another episode with our good friend Spiros. How are you?
Good morning, Chris. I'm fine. How are you?
Good, thank you. So for those that don't know, Spiros is a technical specifications manager for Alspec. And Alspec is a leading industry leader in the supply of aluminium systems.
Yep.
So Spiros, if you just want to talk to us a little bit, just give the audience a bit of a brief on how long you've been in the industry, what your role is, and a little bit about Alspec. That'd be amazing.
Yep. I'm Spiros Contominas. I'm the National Specification Manager here at Alspec. I've been with Alspec for 20 years in March next year. Been in the industry for almost 40 years. So
long time.
2 life sentences. My role is a National Specification Manager. I lead a specification team of 12 people around the country. So we've got specification managers in every mainland capital city. And so we basically assist architects, engineers and builders in specifying aluminium window and door systems and associated products, including things like cladding and solar control and what have you. Yeah.
And how long has Alspec been around for now?
So we celebrated our 50-year anniversary last year in 2024. Started from very humble beginnings. Our founder basically started the business selling telescopic pull handles out of the back of his car, and we've evolved into a multi-million-dollar business with over 800 employees now, over 16 branches around the country. Servicing a wide industry scope. Our tagline is everything aluminium and hardware, and basically we aspire to offer solutions in every area where aluminium or hardware is used.
40 years in the industry has been a long time.
Very long time. Yeah.
So in that 40 years, how much has the industry evolved and changed in your opinion?
Oh, quite a lot, and I think very similar to technology, that evolution has grown exponentially over the last probably 10 years.
Yeah.
In the early days, it was fairly standard systems, no real focus on compliance, whether it was window systems or glass. If you've got a house today with 40-year-old windows, you've probably got float glass in them.
Yep.
They probably rattle and shake. They served their purpose back then. And that evolution has transpired over a period of time, but more recently with some more stringencies in National Construction Code, product specification, product testing, the grade A safety glass issues. So we've seen this massive change, and it's quite interesting because we're seeing a lot of older buildings now needing upgrades because their windows are either leaking or they're letting in too much noise or too much air. And the owners are finding that they're not getting a like for like. So what they see in their building right now changes dramatically to get something that complies to today's standards.
To standards, yeah. So talk to us a little bit about the work that you do with architects and designers and also builders in regards to making sure that you specify products correctly. Yeah. What's the sort of process in regards to that, and talk us through those steps?
So hopefully, architects engage with us early on in the process. We're there to offer advice on the most effective system to use based on their needs. So we'll get a shopping list from them, and that shopping list may include, I want some sliding doors, I want some morning windows, I want them at this height, this width, this configuration. We'll ask them for some information which might include things like what the thermal requirements are for the project, what the wind load requirements are, any special glazing or what have you. And then what we'll do is we will overlay that with our product range our available testing that we've done on certain systems, and we'll give them a list of applicable products.
Yep.
And they may have multiple options as far as sliding doors go, or multiple options as far as fixed glazing go. They might want a centre pocket system or a front glaze system. And then from that, we'll continue working with them to help them to develop some cut-throughs in their drawings, some details on sub-sill design, on sub-head design and all that. We'll engage with the engineer to give them copies of the AS2047 test reports. If there's an acoustic engineer involved, we'll give them access to our acoustic testing. The thermal consultant may ask us for some of the thermal outcomes so that they can determine different glass types.
Yep.
So it's a very sort of long process, or it can be a very long process. And I guess one of the unfortunate consequences, especially with big projects, is sometimes you'll do a whole lot of work and that project may not start for another 2 or 3 years afterwards. So
it's quite a lengthy process. So if you were to give some advice to any designers or architects out there in the early stages of the build, when should they be reaching out to somebody like yourself or a company like yours?
As early as possible. Yeah, definitely as early as possible. We often see designs in their sort of getting to their mature stage, where they've, I'll give you a sliding door as an example. They've designed a sliding door and interpreted something that they've seen on a specification sheet, and put that into their plans. And then when you have a look at it, you sort of say, well, you've gone and designed something that is going to weigh, as an example, 160 kilos, and it's 2 meters wide, and your demographic is 55 years of age plus.
Yep.
How are these people going to physically operate these doors? Because they're heavy and they're difficult to open and close, and that's physics. It's not anything that I can control, it's physics. So, and if they'd spoken to us earlier, we could have sort of directed them around what the optimal sizing of those doors would be, how to configure them so that they were functional but also aesthetically pleasing as well.
And there's a lot of systems available on the market, correct?
There is, yes.
And would it be also correct to say that Alspec spends quite a lot of money and invests a lot of time in the product innovation side and also the testing?
Yeah, absolutely. We're at the forefront of that, and you have to be at the forefront of that, given some of the changes that have happened to the National Construction Code in the last 10 years or so. So we have a very dedicated and very experienced product development team. We've got specialists in window design, curtain wall design, cladding design. But overlaying all that is we've got our own NATA accredited testing facility, which allows us to test for both window and door structurally and waterproofing. We've got an acoustic facility, and we've also got a curtain wall test rig. So we've invested that money to be able to do a lot of that in-house. So you're not relying on third parties who may have capacity or may not have capacity. And certainly testing facilities here in Australia aren't sort of, there's not a lot of them. So you're invariably waiting in a queue to do some testing.
Yeah. And I think it's certainly important to be able to have that access to that readily available, because as the industry changes and develops, designers your design teams are coming up with new systems and new combinations, and we need to make sure that everything is tested.
Absolutely.
Correct?
Yeah, absolutely.
You touched on before AS2047. For a lot of people out there that don't really understand what that is, can you just explain a little bit about AS2047 and the requirements for windows and doors to be tested to that?
So AS2047 is the Australian standard for windows and doors. And within AS2047, there is the section where it talks about how and what you have to test for a window and door system. So we have to test for the structural capability, and that is both the ultimate and the serviceable capability. We have to test for things like air infiltration, which is quite important, and very importantly is for water penetration.
Yep.
So we do very thorough testing of our systems. We try to push them as hard as they can go. And that's sometimes always trying to find a balance again around operating forces and sizing. The other factor that you have to test in AS2047 in a structural test is the operating force of your panel, and you have to record that. And there is a standard in the there is a requirement that for a sliding door, for instance, there is a maximum opening force and a maximum ongoing movement force, and that is quite a generous standard, but where you have something that needs to be accessible for things like schools and commercial buildings and aged care, it's quite a challenging force requirement. So we're going from 180 newtons of opening force in a sliding door in a standard situation to only 20 newtons in a accessible situation.
That's a huge difference.
Massive difference. And that's difficult to achieve. It's difficult to achieve.
So then it's clear to say that the standards and the requirements between commercial and residential applications differ significantly. Would you agree?
Yeah, absolutely, yeah.
But in that, the fundamentals is to ensure that things are tested for AS2047.
Yeah.
Right? And it's a common occurrence that in the residential sector that I see is that we're never provided with the figures that we need to achieve windows in regards to the ULS, which is ultimate limit state, and the serviceability limit state, which is the SLS. But in a commercial application, you see that all the time because it's done by engineers, correct?
Correct, yeah.
So how important, though, is it for a residential application to understand and have access to those numbers?
Look, it's critical. I think, with the residential ratings, there are some ratings in the code in AS1170, which has what we call some standard ratings and some cyclonic ratings. And the standard ratings range from N1 to N5, or N6, I should say. And unfortunately, they're not very well understood. So there's some schematics that show, the level of where a house is located relative to the hill, whether it's at the bottom of the hill, the middle of the centre of a hill, or the top of a hill, and the level of exposure. For instance, if it's got a house beside it, or a park in front of it, or a beach. But unfortunately, what happens is it's very subjective. So someone that might interpret, the location of a home via Google Maps, for instance, might sort of say, well, I'm going to call this an N2, and someone else might sort of say it's an N3.
Yeah.
I always say it should be the builder's responsibility to determine that, because ultimately it affects other things, including windows and doors is one of the things that it affects, but it affects a whole lot of other things as well. The really scary thing is that in a lot of cases, we'll see commercial buildings, and when we sort of say, can you tell us the wind loads, we'll get an N3 rating back. And we sort of have to then go back and explain that this is only applicable to residential homes, and not only residential homes up to 2 levels. So if you build a 3-level home, you can't technically use an N rating. You should be getting that engineered to give you a specific wind load.
And why is that? Because the wind changes as you go higher?
Absolutely.
Yep.
You've got, corner pressures and what have you. And, generally you sort of say, well, the amount of protection you have from surrounding buildings at 2 levels is quite significant. But as you go to that 3rd level, that protection isn't as much, because effectively you might have next to you a building that's only a single level.
Yeah.
So
the wind pressures are going to be higher.
Absolutely, yeah. Absolutely.
And with the higher wind pressures also comes a lot more pressure for the water as well.
Absolutely, yeah.
And how important, in your opinion, is the water Pascal rating and understanding that?
Well, I think it's important in as much as, you know, the structural elements, and if we look at a sliding door, if you get it wrong, then you can take out the panels and replace a mullion fairly easily at, you know, relatively low cost. If you get the water penetration wrong and you have to replace a sill, it changes a whole lot of things and becomes a really, really complicated and expensive exercise. So to get that right is the most important, I think, because the worst thing that can happen is you get water to the inside. That's what we're trying to avoid. You know, we don't want to be destroying, you know, internal flooring. Water to the inside creates a whole lot of issues around, you know, lack of losing access to your space, mold issues, a whole lot of problems. So anything we do to avoid that is a good thing.
Essentially, if you miscalculate that, you're inviting water to come into the building, which then causes a whole heap of problems, right?
Yeah. And it's not gonna leak every time. It's gonna leak in extreme situations.
Yes.
But you don't want it to leak at all.
That's correct.
That's what we need to do, and that's what the National Construction Code demands. The National Construction Code says you're not going to get water to the inside.
So, talk to me a little bit about the differences between the commercial and the residential specifications that you guys work on, and how you've seen that really progress over the last sort of 5 years.
Okay. Look, both of them have, obviously the requirements have both increased over definitely the last 5 years. We're seeing larger openings than what we've traditionally had. So, you know, in most architect design homes now, we very rarely see sliding doors or windows lower than 2.7 high. Whereas maybe 10 years ago, 2.4 was probably the norm. And in a lot of multi-storey apartments, we're seeing doors at 2.7 and 3 metres, which was probably not the norm in the past. With that comes different demands. So the higher you go, the more stronger you need to build your systems. The less movement you can accommodate. Architects and designers like a slimmer looking profile nowadays. It wasn't such a big issue in the past. So we've developed systems with slimmer profiles to accommodate that. Water penetration requirements have increased. So, and we've talked about water quite a bit, but you know, we've seen a change in the climate. So, and we've seen more extreme weather events, not only around the country, pretty much everywhere. And with that, you know, the standards will change. You know, the engineers that are determining these requirements are adjusting their determinations to based on what they see happening in the world. And in addition to that, you know, things like thermal requirements have changed the landscape as well, where, you know, our thermal requirements in commercial buildings changed considerably under NCC 2019, and that necessitated a real push in the non-extreme states. So, you know, obviously in the alpine regions and places like Tasmania and Canberra, we've always had double glaze as the standard.
Yep.
But now we're seeing a lot more double glazing in Sydney, some double glazing in Brisbane, pretty much all double glazing in Victoria now. And under NCC 2019, it's the transition to a thermally broken system to further improve the thermal performance. And under NCC 2022, that's gone across to residential homes. So we're seeing, we're very rarely seeing, especially with homes with a lot of windows and doors, we're very rarely seeing single glazing used anymore. But we're seeing a lot more thermally broken systems, and there's some challenges around those as well, with regard to structural strength and water penetration and new developments and testing and what have you.
So in regards to the thermally broken system, for those that are listening that don't quite understand what that is, can you explain how a thermally broken system is different to a standard aluminium profile?
Yeah, sure. The traditional aluminium system has a web of aluminium that goes from the outside to the inside. Aluminium is a great product to use for windows and doors. Its strength to weight ratio is extremely good. It's easy to coat, whether it's anodized or powder coated. It's 100% recyclable. So it ticks lots and lots of boxes.
Yep.
The one box that it doesn't tick is the fact that it's a fantastic conductor. So heat will go across the aluminium quite readily, and heat generally will go from a hot area to a cold area. So in a situation where it's hot on the outside and you're cooling the inside, you'll get a transfer of heat from the outside to the inside. And there's not much you can do about that if you're using a traditional aluminium system. What a thermally broken system does, it splits the outside web of the aluminium from the inside by using what we call a polyamide strip. So a polyamide strip is a glass reinforced plastic, glass reinforcement for strength, to bring it up to strength. And you effectively join the outside web to the inside web using this polyamide strip. And because it's not a conducting strip, that conductivity is not, you don't bridge that thermal, that polyamide strip. So you get a lot less energy transfer through the aluminium. Couple that with double glazing, so you don't have a single pane of glass where energy will transfer, and you get some significant improvements in the thermal performance. And we measure that by a U value, which is energy transfer per square metre of window or door per degree Kelvin. With U value, the lower the number, the better the performance. So if you took a standard aluminium system using single glazing, you might be getting a U value of maybe 6 kilowatts of energy transfer. And then if you change the glass to a double glazed unit, you might bring that from 6 down to 4. So quite a significant improvement.
Savings, yep.
And then if you took that same glass and changed the frame to a thermally broken system, it might bring it down to 2.2, 2.3, depending on what window type you had. But as you can see, you've come down from 6 down to about 2.2, so quite a significant and step improvement.
And what that sort of means for the end user would be that they spend less on electricity to heat or cool the home.
Yeah, less cooling in the summer months, less heating in the winter months. A big ticket item that sort of is often overlooked is less propensity for condensation. One of the real issues that you see in homes now, especially ones that have got single glazing, especially in the winter months, you get an enormous amount of condensation. You might have, 4 or 5 degree air temperature outside. Inside your bedrooms, you're breathing, you might be heating them, it's 20 degrees inside. That's a fantastic ideal environment for condensation, and you put your hand on the window and it's just wet.
It's the old style windows, right?
Absolutely, yeah. And that's a big ticket item because condensation equals mould.
Yeah.
Okay.
And mould equals problems.
Sickness, as I call it.
Yeah. So let's touch on the commercial AS1428.1 compliance. You mentioned before about the Newton meters of force to operate a door. Talk to us and tell us what the difference is between, your standard residential application where you might not have to have systems that are compliant AS1428.1. And then the commercial applications where you are. What's the big ticket differences between the two?
Okay, so the big ticket differences are firstly flat transition, smooth transition, and there are some guidelines around that, around wheelchair access, as it's called. So with that, you need to maintain an open area, which is generally about 920 millimetres for a wheelchair to pass through.
Yep.
And you can't have any gaps in your sill that are more than 13 millimetres wide. And some people sort of say, well, 13 millimetres is quite narrow. How does that impact a wheelchair? It doesn't, but it does impact someone that's got a walking stick. So we don't want someone walking through that transition and the walking stick gets stuck in a channel or something like that. So that in itself makes it problematic, because if you've got, for instance, a sliding door and you want to run your sliding door through some tracks, you've got to make sure all your tracks are kept quite minimal in that transition. So that is one of the key factors. The other key factor is the operating force, and the operating force is for any door system where someone is, where we call it an accessible path. And that sometimes is a little bit of a grey area, because what we sometimes find in something like a school is that you can potentially create two openings to a classroom area or a hall or something like that, where one is some really large sliding doors, but they don't become the accessible path. You have, for instance, an auto hinge door or a operable hinge door, which becomes the accessible path. But that accessible path needs to be opened potentially by someone in a wheelchair, using one hand, and to be able to open that door with an operating force of no more than 20 newtons. So there are some requirements around, if the door is closing against a jamb that butts up against a wall, to move that operator away from that wall so someone in a wheelchair can access it.
500 millimetres?
500 mil?
Yep.
Yeah. If it's a hinge door, the actual handle has to have a return on it so their hand doesn't slip off when they open it. And then that 20 Newton force is the other key factor. And that in itself isn't an issue, but you've just got to design correctly. So your sliding doors have to be relatively small and relatively narrow. But the other factor is, if you have a hinge door, for instance, in a lot of cases in a commercial building, a hinge door has what we call an auto closer.
Yeah.
So when you open it, it closes by itself. Now that auto closer has to be strong enough to close the door, but not so strong that it's stopping the door from being opened at 20 newtons or less. And that sometimes is a balance, especially where you have larger doors, potentially a double glazed door for thermal insulation. So yeah, a lot of factors, bit of a balancing act. And again, with those type of projects where accessibility is a factor, architects and building designers that talk to their partner suppliers early on in the process can avoid a whole lot of pain later on by sort of designing things at the front end that are going to work.
So then talk to us, how does an architect or a designer get to understand this information from a supplier like yourself? What's involved in doing that? Is there any training for them? Is there?
Yeah. So we offer training in various forms. So we offer CPD courses.
What is CPD? What does it
CPD
stand
is
for?
Continuing Professional Development.
Yep.
So architects have a CPD program which they have to, in order to retain their accreditation, they have to accumulate 20 CPD points throughout the year.
Every year?
Every year.
Okay.
And the CPD process doesn't apply to some states, but certainly on the eastern seaboard it applies to us. And those CPD points can be accumulated either in a formal sense or an informal sense, but 10 of the 20 points have to be formal CPD points.
Okay.
So formal CPD points can come from a variety of ways. It could be sitting in on a CPD seminar that we provide, and a lot of the other industry players provide, people like Dulux and what have you. They could be running a lecture at a university. That could be a CPD point, a formal CPD point. An informal CPD point could be something like attending a trade show in which they mark that down. So there's a number of methods. So our CPD programs are accredited with the Australian Institute of Architects. And they're a 40-minute seminar which gives them one CPD point. So that's process one. The other thing that we offer to architectural practices are what we call a lunch and learn seminar, where we get invited into their practice, or they come here to the showroom here in Sydney, and we run a half-hour to 40-minute seminar on a topic that is of interest to them. So it could be accessibility. Mm-hmm. It could be something as simple as window and door systems. We do lunch and learn on energy so that they can understand what options and how to improve that. So we do a lot of lunch and learns. I think last month we did about 80 nationally across our team.
Yeah.
And then what we also offer more to the regional areas, because the regional areas are areas where we don't get to them every week. We're not as easy to get to. So in the regional areas, we offer what we call a Window Wisdom program, and the Window Wisdom program is an afternoon where we invite the local architects, engineers and builders. It is usually at a location which might be a showroom of one of our partner fabricators. It might be a function room in a motel or a hotel or something like that. We partner with some of our industry partners, so it's not just an Alspec thing. We might be partnering with people like Dulux, people like Interpon, people like Centaur. It's probably about 20 minutes presentation by each of the three suppliers. It's generally three people on an industry topic. Yep. So again, accessibility would be one, performance might be another. Dulux might present on their Duratec range and why you would choose Duratec over Duralloy. Centaur might present something on some of their screening options, and it gives the regional communities some education. Yep. It gives them an update on things that are new, things that are upcoming. We may even do one on, the NCC 2022 as an example, so that people get an understanding of what the key changes were between 2019 and 2022.
Yeah. So talk to me about one of the projects that you've been heavily involved in that due to the specifications, it achieved a great outcome. It could be one of the projects that you might have won an award for, or something that really stands out to you where you've had to be heavily involved in making sure that the specifications were correct and aligned with the architectural or the designer's requirements, that in turn, because it was done right, it was a fantastic project. Mm-hmm. Have you got one of those that you could share?
Look, probably lots of them. Probably one that is probably an iconic project is Barangaroo Apartments. So that was sort of completed pre-COVID. So it was completed 8 years ago now. So it's getting a little bit old. But it's probably one that took a lot of time and had a lot of challenging requirements. So that was 2 apartment buildings at the front of Barangaroo. The buildings in their appearance were different but similar. So similar systems were used. Lend-Lease was the builder. 2 different architects designed the two buildings, PTW for one of them, FJMT the other. Challenging in the sense that it was an iconic building where, these apartments were quite expensive, overlooking, Darling Harbour and in some cases back onto the north side of the harbour. Large sliding doors, challenging wind loads because most of the sliding doors were facing west into the harbour where, you were talking serviceable wind loads at sort of like 2,000 plus and water penetrations in the 500 to 600s. Overlaid with that was one of the buildings was quite close to the Bungalow 8 nightclub, so it had some very challenging acoustic requirements. And we had to look at how we could achieve that and still maintain a reasonably easy to operate system. And that was challenging because we had door panels at 150, 160 kilos. We had specialised glass units which required us to recut all of our double glaze sections for the ProGlide high performance sliding door. Mm-hmm. And that was really good too because we were able then to offer the market a sliding door system that could accommodate a 28 mil double glazed unit, where the industry standard prior to that was 24 mil.
Yes.
And that gave some really good opportunities to others on other projects as well. But yeah, a really, really challenging project, but a sensational outcome. The doors at the end weren't easy to operate, but we struck a balance between operating functionality, weather performance, and acoustic performance.
It's every time that we see specifications come across, sometimes they've got a high acoustic or a high energy efficiency, and then you've coupled, like you just said, the performance ratings as well. It's kind of hard on many levels to make sure that you tick every box, isn't it?
It's really hard. And one of the real issues is most of those requirements affect the other. So, to improve acoustics, you need to have tighter seals, but having tighter seals mean that the operating forces go through the roof. So finding a balance is the challenge. And sometimes you can't always tick every box completely. So it's finding a balance and compromising, I guess. Yeah.
And that's what I wanted to touch on. I just wanted to hear your words, because a lot of the time we see they've got this low U value, but they've got an acoustic rating that is extremely high that you can't achieve in a double glazed unit.
Yeah.
So it's like you've got an acoustic rating to beat, but then you've got an energy efficiency rating. One of them has to essentially give up something,
correct.
Right?
Yeah.
So what is that sort of advice that you would give when that tends to happen? It's, what should they be understanding from your point of view on which direction to go?
Yeah, look, I think firstly, the key is water penetration, in my opinion anyway. That becomes the overrider because you can't afford to compromise on that. The next big ticket item, I think, is acoustics, because the bedrooms, the living spaces have to be livable.
Yep.
And we are building a lot of infrastructure, apartments in particular, on main thoroughfares now. We're building them around, metro railway stations and things like that, which invariably have a main road running against them. And we're seeing a lot more buildings where the acoustic performance exceeds what we've traditionally been able to achieve on a single skin sliding door. But that livability is very important. So the issue then becomes that in order then to also tick the thermal box, that may not be possible.
Yeah.
And the challenge then becomes, what do you compromise on? And the answer to that is that if you can't get a compromise on the thermals, then you have to look at what window types you've got in there, the size of them. And in a lot of cases, the only answer is that you've got to make them a little bit smaller.
Yeah. And increase other elements of the build.
Correct. Yeah.
So that if you're not going to get the acoustic or you're not going to get the energy efficiency, that they've increased other elements to help compensate for that.
Absolutely.
Right?
Yeah. Yeah.
We've touched on a good project that you've spoken about. Could you talk not in so much detail, but give us an example of a horribly wrong project that you've seen and you've just gone, what's happened here, and you've had to assist on over the years?
Yeah, look, we've seen lots of projects where the selection of the systems at the specification level was correct, but unfortunately through a term that is often used, which is value engineering, builders and other people involved in the project have compromised the system and swapped out specified product for inferior product that may not be able to achieve what is required.
What's that term that you're about to say? Equal or equivalent to?
Yeah, equal or equivalent to. And that's a really, really loose wording. Some people sort of think that equal or equivalent to means I've got a sliding door in there, I can throw anything in there.
If it looks the same?
Yeah, if it looks the same, I can use it. What it really means is prove it via a test report. Prove it via a test report. And if you can, fantastic, go for it. But unfortunately, what often happens is that builders, it's all driven by cost. And builders and developers sort of say, well, I need to cut X number of dollars out of this construct, and where do I cut it out? And it's just a bit of glass in a wall. I'll cut it out there.
Yep.
And that's not the only thing that gets compromised, but the net effect of that is that you don't get the thermal comfort that the building was designed for. You may not get the level of waterproofing that the building was designed for. You may be getting a lot more air infiltration because the structural elements are moving with the wind loads a lot more than what they are designed to do. Acoustics is another factor. Obviously, if you've got a building on a main road, there's a lot of different factors. We often go to places and we get told that there's this Alspec door in this building and the homeowners are complaining because there's a whole lot of whistling, or their curtains are moving every time the wind blows and the doors close. And sort of we arrive and it's not an Alspec system. And the architect scratches his head and says, well, that's what I specified.
Yeah.
And you have to sort of give them the bad news that, well, that's not what you got.
Yeah.
Sort of thing.
And would you say that happens a lot in our industry?
It happens less often now than what it probably happened before the building commissioner became as diligent as he did.
Due to all those buildings that were
defected, whether it was cladding, whether it was leaks, whether it was insulation, whether it was waterproofing. There was a myriad of problems, and we know which ones they are. And unfortunately, there's some high-profile ones, but there's many lower profile ones as well, which people have paid good money for and really haven't got what they paid for. Yeah.
So would you then say one of the key takeaways would be that that the end user or the builder really does their due diligence to ensure that they're not getting a copied and pasted system from somebody else?
Absolutely. And the easy way of doing that is show me the test reports. Show me the test reports.
Yeah.
it's a little, that's not a guarantee, because there's been instances where we know that test reports for one supplier have been passed off as applicable to the system that's been installed, and the system is totally different to what the test reports show. But at least the test reports give you some level of confidence that especially if they're dealing with a reputable window and door fabricator. And also what we sort of say is that if you're a builder or you're a developer and you have an Alspec system specified, then and you're looking for a window fabricator, come and talk to us and we'll give you a list of recommended fabricators that we know do that type of work.
Yep.
And have experience in that type of work, because the last thing you want is to engage someone that only knows residential homes and engage them into a commercial project that involves, it might be an aged care facility. And I've got a classic example of an aged care facility where a builder engaged a fabricator who only knew residential, and the rework on that they used the right system, but the installation was atrocious because they installed it as if it was a residential system, not a commercial system. The
ramifications of the incorrect install are huge, right?
Massive. Someone has to go back and fix it. You
Yep.
can't just leave it there. It's and it's not easy to fix, especially when you've got everything else that's already been built around it. Whether it's flooring, whether it's gyprocking, curtain pelmets, all of those factors. To take out a door in its entirety and install it again basically means ripping most of that stuff out as well.
Yeah, and just wanted to touch on how somebody would be able to look up for an accredited fabricator, in your view, in your opinion. Where should they be going? So if someone's listening to this, and by all means, they can flood you with emails and calls and trying to find out from you, but how easy is it for them to try to find somebody? And what due diligence should they do on finding the right person?
Look, we generally will assist. We'll assist. Any of our sales officers, they wouldn't normally come to me, but any of our sales officers can provide that information. The other areas are, check the AGWA website, the Australian Glass and Window Association website, and see if that fabricator that you're considering is a member of the Australian Glass and Window Association. Many aren't, and some that aren't necessarily bad fabricators, but the ones that are, at least that they have been audited by the Australian Glass and Window Association, which is the industry body. And they've been audited not only from a manufacturing point of view, but also from a systems point of view and a knowledge point of view. I've got an example where we suggested to a fabricator to become a member. Because they wanted to branch out into some commercial areas, and we wanted to be comfortable with their processes. And during that accreditation process, what we found out was that they didn't really understand wind loadings. So when they were doing their assessment in their estimation system, they were just putting residential wind loadings into commercial buildings. And AGWA picked that up straight away and helped them to better understand that. And, it was a good thing. It was a great outcome. Yeah.
I think a lot of the time there is good companies out there, but they're just not across all the codes and standards, right?
Absolutely. Yep.
And sometimes they're just operating because they've been in business with their dad or been family or been doing it for such a long time, but they've never gone down that educational path, right? I kind of tend to feel now, and correct me if I'm wrong, but that educational path in today's age is extremely important. Standards are changing all the time, whether it's energy efficiency, structural integrity, water Pascal ratings, elements of the build. It's so important that they, in my opinion, that they are becoming members of AGWA to go and get that technical, because it's available to everybody
Correct.
who's a member, correct?
Correct.
You just need to go out there and seek that information.
Yeah.
Look, I really appreciate you talking to us today, Spiros. What is one of the key takeaways that the listeners could get from you and today's episode on the podcast?
I think, look, we as an industry have a duty of care, and that duty of care involves compliance, I say. And that goes to the livability of the buildings that we're involved with. It goes to the safety of the occupants of those buildings, and it doesn't matter whether it's a school, whether it's a home, or whether it's an apartment building. We don't want to see incorrect product installed in an area where that product may fail. We've seen, in schools, and I think you've seen it as well, Chris, doors falling out because they weren't installed correctly, because someone made an error. We don't want to see that. We don't want to see windows and doors that leak, whether they leak air or whether they leak water, or whether they leak sound. So it's important that what is specified is correct, and we go out of our way, and Alspec as a company invests a lot of money, like I said, 12 specification professionals who live and breathe specification. We interact with architects every day, every waking hour. One of my guys in Melbourne is sending emails to architects at 11 o'clock at night most nights, in between sort of interacting with some of your social media posts, Chris. Compliance is important, but I think there's also a responsibility on builders and developers that you don't cut corners. So, choose a window and door fabricator who has some accreditation, who can support his product through demonstrating other similar project supply, and use products only that are tested to the Australian standard. There are lots and lots of products on the market that claim compliance that are not tested to Australian standards. And we just need to be very careful of that, because our wind loads here in Australia are much, much more severe than what they are in other parts of the world. Even some of the European systems that come in are great systems, but you can't just bring that European system and lob it into Australia, because when it goes into a test rig, it invariably will leak, and it needs some subtle changes made to it to stop it from leaking.
Well, Spiros, thank you very much. I really appreciate your insight, and I hope that the listeners can get some valuable information here on the Build Better podcast.
Thanks very much,
Thank
Chris.
you.
Thanks for the opportunity.